Hello again. So we are back talking about systems of equations and inequalities, and this time we're going to be focusing more on the inequalities, so systems of linear inequalities. And we're going to do a couple of examples from your worksheet. Before we do that, though, I just wanted to review a couple of different things that was talked about actually in the last unit when the idea of inequalities was presented to you guys. So the first thing I wanted to talk about is the type of line that you guys are going to be using in your graphs. Remember that if we have the or equal to, whether it's a greater than or equal to or less than or equal to, it means that the line is included in your actual graph. So we're going to be using a solid line if you have the or equals to. If you don't, if it's just greater than something or less than something, then you're going to be using your dotted line. Okay, so that's actually a really, really important distinction there. Secondly, we need to talk about where to shade. Remembering that with inequalities, we shade above or below the lines. We need to kind of think about, which is which side do we actually shade. Now, I know on NROC they ask you to choose a point and double check and see which point works, either above or below the line, and then you shade in that region. But you can also just look at your inequality sign. If you have greater than or equal to or just greater than, this word greater, anything greater means up, it's above, it's more, right? So that's when you're going to be shading above that line. Okay, and of course the opposite is true. If you have less than or equal to or less than, we hear that word less. Well, less is below, it's going down, so we shade below. So it's important for us to kind of think about that before we begin. All right, guys. So remembering that a system of inequalities is the solution, I should say, to a system of inequalities is any point where the region of overlap of the shaded areas. Okay, so basically the idea here is just graphing these two inequalities, shading them, and then we're looking for the overlap. That's the solution region. So it's asking us in number 1 to sketch the solution to each of the system of inequalities. Okay, now when you're going to graph these things, when you're about to graph these things, you can just treat them like they're equations. Because that we really are graphing them in the same manner. It's just that we have to kind of pay attention to the inequality sign, and I like to do that ahead of time just so that I know what type of line that I'm going to need. Now you can see that both of these equations, the first and the second, have an or equals, so I know that I'm going to be using a solid line with both of these. The first equation, let me go ahead and let's go ahead and use this as the first equation. That's actually convenient. And let's use this guy. This color is the second one. For the first equation, we've got a less than or equals to sign. So I'm going to be shading below. And in the second equation, we have a greater than or equal. So I know that I'm going to be shading above. I mean, I can do this ahead of time if I want, just to kind of let myself know what I'm going to be doing once I get to that graph. The other thing I want you guys to be super careful of, and we don't actually have an example of this on your worksheet, but you will have this as an example. Make sure before you go to graph these, make sure that you write in standard form. Okay, and of course this is just one standard form, but the standard form that we've been using in this class is y is equal to mx plus b. And I know we're not using an equal sign for these inequalities, but I'm just going to write it this way just so we have the basic idea. The reason is that if we had something, for example, let's say we had a negative 2y is equal to 4x plus 1. No, let's say plus 8. Let's do that. Plus 8. And, oops, not equals. Let's say we have a less than or equal to sign here. We remember from when we were learning inequalities that when we divide by a negative or when we multiply by a negative, in which case we do here, we have to flip that inequality sign, right? So this would eventually look like y is greater than or equal to negative 2x minus 4. Right? That looks very different from the original equation, and we know we're going to the solution region is going to be above the line versus below the line. So in essence, guys, if you ever have a negative coefficient in front of your y, and it's maybe written in a way that's not in standard form, please go through the process of getting it into standard form so that in the end you can see what you're really supposed to be graphing. Okay, so that would be one heads up that I would give to you guys. All right, in question number 1, we're not really having to deal with that, so that's good. And since these are already written in standard form, this would be an easy one just to go ahead and graph from the equation itself rather than a t-table or intercepts. So remember, we start with plotting the b. So in equation number 1, our b is negative 2. And right here we can see this negative sign right here. This is our m. Right? Well, this just means negative 1 over 1. Negative 1 over 1 is the same as negative x, right? Negative 1x. So that would be either a negative 1 over a positive 1, or it could be up 1 on our rise, oopsie, and minus 1, oopsie. Could be just switched. I could just switch these. And you see I'm already down pretty far on my graph, but I can go down 1 and a positive x, or I could go up 1 on my rise and a negative on my x. You can see that all of these points are still in line with each other. And we know that it's going to be a solid line. We've already decided on that. We also know that we're going to be shading below this line. Okay, so all this region in here is going to be our solution for equation number 1. Now, let's skip to number 2 here. So it looks like our y-intercept is up here at 0, 2, and our slope is negative 5 over 1. So let's go down 5 and a positive 1. Okay. I don't have room to do any more than that on my graph, so I'm just going to do the 1 point here. All right, and I know that I'm going to be shading above this line. It's almost a vertical line, so we have to be kind of careful of that, but above is to the right there. And the one thing that's kind of hard to see sometimes is, okay, where is that overlap? But we can see right here in this area, we have pink and we also have black. So this down here, just this little chunk, this little triangle at the bottom right here is our solution region. And all we would have to do is to pick a point in that shaded region and try it just to make sure that it works. Now it's kind of hard to see because I kind of shaded it pretty darkly here, but if we were to pick a point at 2 negative, let's see, 1, 2, 3, 4, 2 negative 4. Okay, so 2 negative 4, let me just use a different color here. Maybe we can find it right here. Okay, so let's try 2 negative 4. Now we remember that when we have a system of inequalities, it has to work for both, right? I could try it in one and it could work, but if it doesn't work in both, then that's a problem. Okay, so let's try that here. So 2 negative 4. Okay, so let's do that. So here we've got a negative, this is for equation number 1. So we've got negative 4, and I'm just going to leave those in blue. So we've got y is less than or equal to negative of the 2, because this is my x and my x is 2, so the negative of 2 minus 2. So negative 4 is less than or equal to negative 4. Well, it is not less than, but it is equal to, so it's still true. Okay, let's try it over here. So we've got negative 4 greater than or equal to negative 5 times our x, which is 2. That's what we're testing here. So negative 4 is greater than or equal to negative 10 plus 2 is negative 8. Negative 4 is definitely greater than negative 8. So this works as well, so we're super happy. Now I want to just bring up a point here about this, that if we chose something over here, let's say, and we were try to plug this point in, so this would be at 2, 2. When we plug this into equation number 2, it would work, and we can see that because the coordinate 2, 2 is in the shaded region for equation number 2, but it is not in the shaded region for equation number 1. So when we plugged in that coordinate for equation 1, it would not work. And similarly, if we chose, for example, this point, negative 3, negative 1, this would work for equation number 1, but would not work for equation number 2. So this is the idea here, is that we're checking a point in the overlap of the shaded regions and making sure that our solution is correct. All right, I just wanted to try one more of these. I'm going to scoot all the way to number 6 here. Okay, let's do that. Just looking to see if there was a better one to do, but I think that one's still good. Let's do that one. All right, so this is already written in standard form, which is nice. Let's just look at our signs to start with. Okay, I've got a greater than or equal to, and I've got a greater than. So let's talk about the type of line first. Greater than or equal to, we know, going to be solid. Greater than, though, is going to be dotted, isn't it? Dotted. And these are both, these both have greater than in it, so we are going to be shading above on both of them. All right, we'll call this equation 1, we'll call this equation 2. Equation number 1, let's start there. So we're going to plot our point at 0, 3, and we have a slope of 2/3. So we're going to go, now you guys notice that I don't have a lot of room here. I could go up to 5 and then over 3, but I'm almost off my graph, aren't I? But that means I could make them both negative. A negative 2 divided by a negative 3 is still a positive because we've got 2 negatives. So I could go down 2 on my rise, and I could go negative on my run, and I could plot that point, and you can see that it's all in line with each other, so we're good to go there. And I'm going to be shading above. Okay, there's not a whole lot of room here, but we got some room. All right, let's go to our second equation. This time our y-intercept is at 0, negative 3, and we've got a slope here of negative 4, 3. I don't have any room to go down negative 4. You guys see that? I would be off of my graph. So I know that that's exactly the same as going up 4 and a minus 3. It's still a negative slope, right? It's still going to give me a negative number, so that works just fine. So I'm going to go up 4. 1, 2, 3, 4, and negative 3. 1, 2, 3. Okay, so we can see that's going to intersect the other line right there. And I'm shading above. Okay, so you can see there's some shading here, but we can really see that this area in here is where it all happens. That's the good stuff. That's what we're interested in right in here. And once again, you guys, if we were to choose a point in that region and double check it, it would have to work for both of those equations, and indeed it would. Okay guys, so you have a few more to practice. I'm going to, in the next video, going to be working on one of these application problems. So we'll see you soon.